Okay, so today we are going to discuss a new topic of this subject, that is alternative fuels and engine tribology. The fundamental today's topic is the fundamental of lubrication. So lubrication, whenever we are needing some reduction in the friction between two matting surfaces, we need lubrication, uh, and for that purpose we use some lubricating fluid, mostly the oil. So this kind of lubrication and this kind of activities is required whenever we are trying to reduce the wear and tear of two matting parts whenever they are sliding or rolling over each other. तो सबसे पहले हमारा जो टॉपिक है वो है lubrication regime. तो regime हम कह सकते हैं कि ये एक तरह का फिनोमिना है जो कि मैटिंग सरफेसेस के बीच में डायनामिक्स में जब चेंजेस आते हैं तो उसके हिसाब से हमारा जो लुब्रिकेशन है वो चेंज होता है. सो व्हाट इज़ अ लुब्रिकेशन रिजाइम? रिजाइम वो हम ऑलरेडी डिस्कस कर चुके हैं. ठीक है, तो नेक्स्ट इज द डिग्री ऑफ लुब्रिकेशन बिटवीन टू मैटिंग पार्ट्स. हाउ मच लुब्रिकेशन वी आर required between two matting parts when whether the parts are sliding over each other or rolling each other. So according to sliding and rolling, the regime will be changes. So in that context we have two important terms like peak and valleys, that is related to the roughness of the matting surfaces. Peak, it's like the material which is overheaded from the surface, mean surface of the material. And the valley is the pit, it's like a pit, so it will goes under the mean surface layer of the surface material. So that will define the variation between peak and the valley will define the roughness of the matting surfaces. जितना ज़्यादा रफ सरफेस होगा उतना ज़्यादा हमें लुब्रिकेशन करने की ज़रूरत पड़ेगी, और जितना ज़्यादा एम्पलीट्यूड होगा पीक और वैली के बीच में उतना ज़्यादा हमारा सरफेस जो है वो रफ होगा. सो उसको ध्यान में रखते हुए हमें रिजाइम जो है वो स्टडी करना है. नेक्स्ट इज़ द वर्किंग कंडीशन. वर्किंग कंडीशन डिपेंड्स अपॉन द लुब्रिकेशन सिस्टम वेयर द मटीरियल इज़ having contact between two having contact, and some of the parts are matting to each other, like metal to metal contact between two matting surfaces, and the force between these two materials are very high. So the working conditions like sliding, rolling, and the load between two matting parts will define the lubrication system. So now what are the types of lubrication design? There are four types of lubrication design. First is boundary layer lubrication, second is mixed layer lubrication, third one is hydrodynamic lubrication, and fourth one is elastodynamic lubrication. So each of these design will occur according to the different working condition and the working sliding and rolling of two different matting materials. So first of all, the boundary layer lubrication. The boundary layer lubrication having the metal to metal contact of two sliding materials. Here is the most important term to notice is the sliding of two materials. Here, what are the characteristic of boundary layer lubrication? There is a 90% of load is rest on the surface peaks. So peaks or valleys we have discussed already. So peaks, the 90% of load will be rest on the peaks. It means the load is very high between two matting surfaces while they are sliding at very slow speed. Then it occurs during the condition where the asperity of two lubricating surfaces in relative motion may come into physical contact and potential of abrasion and adhesion occurs. If two materials are sliding over each other, because of the roughness there is adhesion and abrasion. So abrasion will remove the material from the surface. It will cause the wear and tear. So in that case the asperity of two lubricating surfaces have the have the relative motion, that is sliding motion, and because of that we have to provide the lubrication between two surfaces. Then provide the lubrication. For boundary layer lubrication, we have to provide a correct lubricating viscosity of the correct viscosity of a lubricating oil. That is the main feature of this type of boundary layer condition. So what we called as a boundary layer condition, where there are two significant points to be noted. First is to the maximum load is rest on the piece, that is the 90% load is rest on the surface peaks, and another is the uh, lubricating oil will have a certain viscosity to provide the lubrication between these two matting parts, which are exactly at the position of sliding, and sliding is very small, uh, very less relative motion between these two matting surfaces. Okay, so the next type of uh, boundary layer next type of lubrication is regime is mixed layer lubrication. So in that the change is the speed, the sliding speed is dramatically change whenever there is a sliding of two material. That is the intermediate range of lubrication from boundary layer lubrication to hydrodynamic lubrication. So at that point the sliding speed increases drastically. Okay, so creating a wedge of lubricating film between the surface in the motion. So in previous there is a sliding between two matting parts, first one this matting surface and another is this one. So these two matting parts are having opposite velocities of sliding in opposite direction. Okay, but in this the majority the oil is making a wedge. Wedge means a layer, a constant layer between two matting parts. So there is still the metal to metal contact between two matting parts, but the majority of load is carried by the wedge, and that is because of the drastic change, that is the increment in the sliding speed of the two matting parts, relative velocity of the matting parts. Okay, so this is the intermediate condition between boundary layer lubrication and hydrodynamic lubrication condition. The next is hydrodynamic lubrication, third one, that is it occurs when full film of oil supports and create a working clearance. So कैसा होगा कि यहाँ पर स्पीड जो है वो बढ़ जाएगी, स्लाइडिंग स्पीड बहुत ज़्यादा होगी. उस कंडीशन में क्या होगा कि जो मेटल पार्ट्स हैं वो टोटली एक दूसरे से अलग हो जाएंगे, और उनका जो सेपरेशन होगा, वो जो क्लियरेंस होगा, वो हमारा lubricating ऑयल कवर करेगा. So there is a constant, you can say a layer between two matting parts, a layer of lubricating oil between two matting parts. For example, the rotating shaft and the general bearing. It occurs when a wedge of oil has been formed between the shaft and bearing surface while the rotation of the shaft starts. So जब हम स्लाइडिंग की बात कर रहे थे तब वहाँ पर हमारी स्पीड बहुत स्लो थी. सेकंड कंडीशन जब हमारी फर्स्ट बाउंड्री लेयर कंडीशन में हमारी जो स्पीड थी वो बहुत स्लो थी. फिर मिक्स्ड लेयर के अंदर स्पीड जो है वो इंक्रीज़ हुई. अब जो है स्पीड काफ़ी तेज़ है, जिसको हम रोटेशन में काउंट कर रहे हैं, और जो मटेरियल है, मैटिंग सर्फेसेस हैं, वो एक दूसरे से अलग हो चुके हैं, और जो क्लियरेंस है वो हमारा लुब्रिकेटिंग ऑयल ने कवर कर लिया है. ठीक है. The next is it must be high degree of geometric conformity between the machine component. Conformity is geometric conformity matlab the surface should be similar. If we are having two flat surfaces, the flatness of these two surfaces should be similar. If we are having two round surfaces, the surfaces should be similarly round. There is no change in the roundness of that surface. Okay, so the conformity is the similarity in the design and the surface. Okay, here we are not talking about a flat surface is rolling over a round surface is rolling over a flat surface. So that is not the condition of hydrodynamic lubrication. Okay. Then next is the film oil. The film uh, is typically of the order of 2 micron, less than 2 micron. Okay, so the film is very thick, and that is, instead of having such thin layer, the parts are separated from each other because of the high speed rotation of the matting parts. Okay. The next one is elastrodynamic lubricating oil. Elastrodynamic lubricating oil generally occurs between two rolling materials, two rolling matting parts. If two matting parts are rolling over each other, okay, so the contact zone has uh, lower degree of conformity. Lower degree of conformity means lower surface contact, lower surface contact. Okay, so the in that context, the metallurgy and the heat treatment of the metal are very important to this lubrication design, because at the time of lubrication, the layer is very thin and the load is very high. In that case, you can see here is a deformation. Here is the deformation of both the materials. Both the materials means the two matting parts. First is the bearing and another is the shaft, maybe. So the bearing is roller of the bearing is rolling over the shaft surface, and that will creating the deformation of some extent, and that deformation is taken care by the lubricating oil. So the layer of lubricating oil will change throughout the operation. Okay, so in that case, the heat treatment, because the deformation range will be decided on the basis of heat treatment and metallurgy of the material. The oil film thickness are often in the order of 1 micron. 1 micron means जहाँ तक हम पहले layers की बात कर रहे थे, तो वहाँ पे 1 माइक्रोन से थोड़ा ज़्यादा था, 2 माइक्रोन था. अभी यहाँ पर 1 माइक्रोन है. 1 माइक्रोन मतलब बहुत ज़्यादा छोटा. उसके अलावा जो है, जब हम इलास्टो हाइड्रोडायनामिक लुब्रिकेशन की बात करते हैं, तो जो डिफॉर्मेशन है वो हमारा इलास्टिक डिफॉर्मेशन है मेटल्स के अंदर. इट मीन्स जब वो डिफॉर्म होगा और जो सरफेसेस रहेंगी मैटिंग के टाइम पे, वो सेपरेट होंगी हमारे लुब्रिकेटिंग ऑयल के, और जैसे ही लोड हटेगा वो डिफॉर्मेशन चला जाएगा. लेकिन ये कब हो रहा है? जब हमारी कंडीशंस जो है वो डायनेमिक कंडीशंस हैं. उस केस में हमारा लुब्रिकेशन होता रहना चाहिए. सो दैट इज़ व्हाट वी वांट. So small temporary deformation is there. Okay, so these are the four these are the four different type of lubrication design that we have discussed today. That is all for today. Thank you very much.